Alright, show that the roots of the equation x squared plus px plus p is equal to 1 are rational for all values of p. This is the nature of roots question. It's a show that or prove that question, and the method is we need to write the equation in standard form first, identify a, b, and c from the standard form. Write down delta is equal to p squared minus 4ac, which is the discriminant. Substitute a, b, and c into the delta, p squared minus 4ac, get delta as the expression, then make a conclusion based on delta and the statement above. So we are going to actually approach this, and we are going to do it and see how we go about doing it. So x squared plus px plus p is equal to 1. The equation is currently not in standard form. Now what we do is we write it px plus p minus 1. We transpose the positive 1, we get minus 1 on the left hand side. This equation now is officially in standard form. Our a value, which is the coefficient of x squared, is 1. Our b value is actually p, positive p, and then our c value is p minus 1. Alright, oftentimes we know that our constant is a numerical value, but in this case it is actually an expression with the other variable p, which we are supposed to actually find the value of. Then step that follows is we need to write down delta is equal to p squared minus 4ac, which we refer to as the discriminant, equal to, now b, we substitute b is equal to p, so p squared in brackets minus 4a, which is 1, c, which is p minus 1. Then we multiply out p squared into p squared into p is p squared minus 4 times 1. 4 times 1 is negative 4 into p minus 1. Then what we do is we distribute the negative to the negative 4 to the p, which is minus 4p. The negative 4 into negative 1. Negative times the negative is positive, so we have positive 4. This trinomial is a perfect square trinomial, and we can actually factorize it into p minus 2 into p minus 2, which is p minus 2 squared. Now this here is what we call a perfect square. It's a perfect square, and it is basically an expression that is a perfect square. So therefore we say delta is a perfect square. And therefore, if we look at what we were supposed to prove, we were supposed to show that the roots of the equation x squared plus px plus p is equal to 1 are rational for all values of p. Now we know when the delta is a perfect square, it means that the roots indeed are what? Are rational. That we can conclude without a shadow of doubt. Now it says for all values of p. In other words, any value of p that we substitute here, we substitute 0. 0 minus 2 is negative 2. Negative 2 squared is 4, which is basically means we always get a perfect square, which means delta is a perfect square, and therefore the roots are rational. For any value of p that we substitute here, it doesn't matter what it is, whatever value we get here, we're going to square it, and therefore it's going to be a perfect square, which means indeed that the roots are rational, and it is indeed for all values of p. Whatever value of p you substitute here will lead to this being a perfect square, and therefore we can conclude that the roots are rational for all values of p. If you have any questions, please let me know in the comment section. I'll be happy to answer any of your questions, but that is one of the questions in nature of roots. It's referred to as show that or prove that, and that's how we go about answering it.